Children, see, in the last video, we studied about this positive charge, okay, flowing from a point of higher potential to a point of lower potential, okay, and that is, we saw the potential difference and how the electricity flows also, isn't it? Now, see, today we will study about potential difference of a cell. The difference in potentials between the positive and negative terminal of the cell is potential difference of that cell. Now what is this potential difference? That is, that is the positive charge, okay, is at higher potential and negative charge is at lower potential. So the difference in potential which is there between these two terminals of the cell, okay, we call it as potential difference of that cell. Now see, this potential difference is caused by chemical reactions occurring inside the cell. The potential difference sets the electrons in motion and results in the flow of electricity through a conducting wire connected to the two ends of the cell. Now see, what is going to happen is the potential difference, okay, that is why this potential difference is created, is caused. It is because chemical reactions takes place inside the cell. Now what happens is when you take, that is, the electrons get attracted towards the positive, that is the protons. Now when you bring electrons near the protons, what happens is acceleration is created, and because of the force, okay, the electrons start moving towards the protons with an acceleration, and the acceleration goes on increasing as the electrons move towards the protons. Now you think you're throwing a ball from a height. Now what happens is the ball falls down with an acceleration, isn't it? And the acceleration becomes zero when it touches the ground. Now see, what happens is, see, and that is the gravitational potential energy which is there is converted into kinetic energy, and that is why the ball starts moving. Now here also same thing happens, and electric potential energy, okay, is there in the electrons, and therefore this energy gets converted into kinetic energy, and that is why the electrons start moving towards the protons. Now see, the amount of work done to carry a unit positive charge from point A to point B, okay, yes, is called potential difference between the two points. Now what is this potential difference, electric potential difference? So see, wait, I'll show it to you. The amount of work done to carry a unit positive charge from point A to point B is called the electric potential difference between the two points. So whatever work is done, okay, to carry a single positive charge from point A to point B, okay, that we call it as electric potential difference between the two points. Now see, potential difference, okay, between two points is given by work by total charge carried. Now see, the potential difference, okay, that is the work done, okay, to carry a that is single positive charge from one point to the other point, isn't it? So whatever work is done, okay, divided by total charge carried, so that is the potential difference between the two points. Now that is equal to, so potential difference is given by V, okay, so V is equal to work, that is W, by total charge, charge is given by Q. So W by Q. So unit potential difference, okay, is the work done, okay, to carry, that is to transfer an unit charge from one point to the other point. So that is the unit potential difference. Okay, so the unit of potential difference in SI system is given by volt. Okay, so always remember this, that is the unit of potential difference is what? Volts. Okay, so V is equal to W by Q. Okay, now see, once again let me tell you what is this unit potential difference. Unit potential difference is defined as the work done, okay, to carry an unit positive charge from one point to the other point. Now this charge, okay, the unit of charge is given by 1 coulomb. 1 Siemens what? 1 coulomb. And work done, W, is given by 1 joules. The unit of work is joules. Okay, now see the free electrons. You can see the electrons which are free. Okay, see the electrons you can see over here, those are the free electrons. Now these free electrons, they are going to move from one point to the other point. So weakly attached outermost electrons you can see. Okay, so these electrons, the free electrons, they will move freely from one atom to the other atom. Okay, so an introduction to scientist. The Italian scientist Alessandro Volta constructed the first electric cell. So the unit of potential difference is named as volt. Okay, so you know I told you the unit of potential difference is volt. Okay, so this is named, that is, this is named on Alessandro Volta. So the unit of potential difference is volt. So this Volta's simple electric cell. Now see, do you know, very small values of potential difference are expressed in the following units. Now this which is there, okay, the conversion which is there, this is very important because you get it in MCQ questions. Okay, so 1 millivolt, okay, is equal to 10 to the power of minus 3 volts, and 1 microvolt is 10 to the power of minus 6 volts. So large values of potential difference, if the values are large, okay, then you know we always mention it in kilo, isn't it? So 1 kilovolt is equal to 10 to the power of 3 volts, and 1 megavolt is equal to 10 to the power of 6 volts. Okay, so this is important. Okay, 1 kilovolt 10 cube volts, and 1 megavolt is equal to 10 to the power of 6 volts. So this conversion which is there, okay, you will have to learn it off. It's important. Now see, free electrons. Every atom of a metallic conductor has one or more outermost electrons. Now you know the metallic conductors which are there, they are that is the metals which are there, they are very good conductors of electricity. Now why they are very good conductors of electricity? Because they are having one or more outermost free electrons. Okay, they are having one or more outermost electrons, okay, which are weakly bound to the nucleus. Now what happens, you know, this electrons which are there, okay, they are weakly bound to the nucleus, and because they are weakly bound to the nucleus, they can easily move from one point to the other point, and because they can move from one point to the other point freely, okay, they are called as free electrons. They are called as free electrons. Now see, as shown in figure 3.3, these electrons can easily move from one point to the other point, okay, from one part of a conductor to its other parts. The negative charge of the electrons also get transferred as a result of this motion. The free electrons in a conductor are the carriers of negative charges. Now in this diagram you can see this is 3.4. Okay, see 3.3, you can see what happens is this electrons which are free, okay, I have shown it to you actually, this electrons which are freely attached. Now see, let me show it to you once again. See this electrons, okay, which are free, okay, which are that is loosely bound to the nucleus. You can see the nucleus is over here. Now in the metallic conductors, what happens is there are some electrons which are weakly bound to the nucleus, and these electrons which are weakly bound to the nucleus, they that is they move from one part of the conductor to the other part of the conductor. You can see here. Now see, because of this, the current electricity, that is the current, will be passed from one place to the other place. Okay, now so the free electrons, they are the carriers of negative charge. Now current flowing through a wire. Okay, yes, see as shown in the figure 3.4a, you can see this is 3.4a figure. Okay, okay, so this is the figure we are going to refer now. As shown in the figure 3.a, if a conducting wire is not connected to a cell, its free electrons move randomly in all directions in the space between the atoms. When we connect the ends of the wire to the two terminals of a cell, electric force acts on the electrons. Being negatively charged, they start moving from the negative potential to the positive terminal of the cell. So, as shown in figure 3.4b, due to the flow of these electrons, okay, see, due to the flow of these electrons, current starts to flow through the wire. This motion of electrons is irregular, but there is definite non-zero value to their average velocity. Now, you know what happens is, see, you can see in the figure A, okay, when the ends are not connected, okay, to the battery, that time what happens is the electrons, you can see, they are moving randomly. Okay, yes, you can see here they are moving randomly. See, this is moving this side, this electron is moving this side, this is moving this side, this is moving. So the electrons are moving here and there randomly. Okay, yes, in all the directions. Now when you connect it to the ends of the terminal, you can see over here the, see, I will show it to you. Now see here, okay, the two ends, they are connected to a battery, isn't it, to the two terminals of the cell. Now here what happens is, okay, the electrons, okay, they start moving from the negative potential. Okay, so you can see this end, okay, is attached to the negative potential, and this terminal which is there, this is attached to the positive terminal. So the electrons which are there, they will start moving, okay, from the negative terminal to the positive terminal. So in this way they are going to start moving. Now see, that is they move from the negative, okay, to the positive terminal of the cell. You know, the negative terminal which is there, okay, yes, this negative terminal which is there, that is at a lower potential, okay, and this is at the higher potential. So the electrons start moving from lower potential towards the higher potential. Now due to the flow of these electrons, you know, current will start to flow through this wire. Okay, so current will start flowing in this wire. This is the wire. Okay, so the current will start flowing through this wire, and see, this motion of electrons, okay, it is irregular but it is definite. So non-zero value to their average velocity. So what will happen? Their value, now it will not be zeros. There will be some value to their velocity because they have started moving. Okay, so you can see the direction of flow of electrons towards this side it is. Now electric current. An electric current is the flow of electrons through a conductor. So what is this electric current? Electric current is the flow of electrons. This definition is important. Okay, so an electric current is the flow of electrons through a conductor. Quantitatively, current is defined as the charge passing through a conductor in unit time. Now you know this. Okay, electrons are the charge carrying. Okay, isn't it? So this, the charges, they start, that is the electrons will start flowing from one part to the other part. So that is why, current is defined, okay, as the charge passing through the conductor in unit time. See, current is defined as the charge passing through the conductor in unit time. So in unit time, in 1 second, okay, 1 minute, unit means what? Single. So the current which is passing, the charges which are passing through a conductor in unit time, okay, that we call it as current. And current is denoted by I. Okay, current is denoted by I, charge is denoted by Q, and time is denoted by T. So, okay, if charge Q is flowing through cross section of a conductor in time T, then the I is given by current, Okay, what is current? Current, how you defined it? It is defined as the charge. Okay, see, it is the charge. Okay, see, I'll show it to you properly. See, the current, okay, is defined as the charge passing through a conductor in unit time. Okay, yes. So I is equal to Q by T. So this formula is important. Okay, I is equal to Q by T. The unit of charge in SI system is Coulomb. Okay, so the unit of charge is what? C, that is Q, you denoted as Q, right? But the unit of Q is what? Coulomb. Okay, C. So current is expressed in amperes and the charge of one electron. Okay, the charge of one electron is 1.6 into 10 to the power of minus 19 coulomb. Okay, so this is the charge of one electron. Now always remember, see, I, the unit of current is amperes, the unit of charge is coulomb, yes, and the unit of time is T, that is seconds. Okay, so this units which are there, this is very important. Always remember this. This is going to help you in your further classes also. Now the definition of ampere, what is, can you tell? Yes, tell what is this ampere actually is. It is the unit of current, isn't it? So 1 ampere current is said to flow in a conductor. See, 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it every second. Okay, so 1 ampere. Okay, just now we saw the definition, okay, of current, isn't it? I is equal to Q by T. Now what is this ampere? How we are going to define this unit ampere? See, 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it every second. You know the definition, I is equal to Q by T. So if this is going to be 1 ampere, okay, Q is going to be 1 coulomb, isn't it? This is going to be 1 coulomb and time also is going to be 1 second, right? Yes, so this ampere, how we are going to define 1 ampere current. See, I'll show it to you once again. See, 1 ampere current, okay, is said to flow if a conductor of 1 coulomb, okay, charge flows through it every second. So every second, how much of charge has to flow? 1 coulomb of charge has to flow. Then only you will say that 1 ampere current is flowing through that conductor. Now, do you know, very small, see, let me tell you once again, see, this formula is important. I is equal to Q by T. Now see, do you know, very small values of current are expressed in the following units. Okay, now again, this conversion, okay, 1 milliampere is equal to 10 to the power of minus 3 amperes, and 1 microampere is equal to 10 to the power of minus 6 amperes. Okay, so this conversion you will have to learn it off. The French mathematician and scientist Ampere conducted a number of experiments on electricity. Today we can measure the current flowing in a conductor only because of his extraordinary work. The unit of current is called ampere in recognition of his great work. Now see this, you can see at the side photo is given to you. That is, who is this scientist? Yes, the scientist, okay, he is a French mathematician, okay, and his name is Ampere. He conducted a number of experiments on electricity. Now because of him, okay, we can measure the current flowing in a conductor because of his extraordinary work. So the unit of current has been given as ampere in recognition of his work. Now see, there is a problem related to this, okay. Yes, a current of 0.4 amperes, okay, so current of 0.4 amperes. So what is this? I, isn't it? So I is equal to 0.4 amperes is flowing, okay, through a conductor for 5 minutes, okay. Yes, 5 minutes. So what is this 5 minutes? This is time. T is equal to 5 minutes, okay, but it's given in minutes means you will have to convert it into seconds, right? So 5 into 60, that is equal to 300 seconds. So how much charge would have passed through the conductor? So you will have to calculate the charge. You know, charge is given by Q, isn't it? So I is given to you, okay, and T is given to you. You will have to calculate Q. So you know the formula, I is equal to Q by T, right? Yes, so I is equal to 0.4 amperes, T is equal to 300 seconds. So I is equal to Q by T, okay. Now I is given to you, T is given to you, so you'll have to calculate Q. Now cross multiplication, okay. So Q is equal to I into T you will get. So just substitute the values. I 0.4 amperes into 300 seconds. So you will get it as Q is equal to 120 coulombs, okay. So charge passing through the conductor is equal to 120 coulombs. Now resistance and Ohm's law, okay. So this resistance and Ohm's law we will continue in the next video, okay. Yes, now see, in this lesson, you know, in today's video, okay, we studied about how the free electrons, okay, the potential difference of a cell we studied, right, and how the free electrons, they are moving from one part of the conductor to the other part of the conductor, okay. That is only the that is the current flows through the conductor, and we have seen this formula, V is equal to W by Q, okay. So this formula is very important. We saw some of the conversions, yes. So those conversions, this formula I is equal to Q by T, this formula also is very important. And one more thing, I'm revising this to you because this is very important. The unit of current, okay, is given by amperes. The unit of potential difference is given by volts. The unit of charge is given by coulomb, and the unit of time, okay, is seconds. And that is I is denoted for current, Q is denoted for coulombs, T is for time, V is for volts. Okay, yes, so all these things are important. 1 milliampere is equal to 10 to the power of minus 3 amperes. 1 microampere is equal to 10 to the power of minus 6 amperes. Now we saw one problem also regarding this. In the next video we'll understand this resistance and Ohm's law. Okay, yes, that is Ohm is the unit for resistance. So we will see that is a law regarding this resistance, that is the Ohm's law. So let us continue this in the next video.